The perimeter of a rectangle is 257 feet. The length of the rectangle is 1 foot more than triple the width, or the length and width of the rectangle. So I'm gonna actually draw a rectangle here. Do you have to do a drawing on the exam or any of the assignments? No. But if you do it, you may find that it's helpful. So there's my little rectangle, and I'll call this my width. The short side my width, and the long side cursive L for length. Okay, now we know the perimeter of a rectangle is where you take, I'm gonna write this out here, but if you want the perimeter specifically of a rectangle, you just add all the side lengths together. And so for us, we're gonna take a length and a width. Now that's only 2 of the 4 sides though, so you need another 2, right? So you need another length and another width. That's all 4 sides. Of course, there is another way to write this equation, but I prefer to see all 4 side lengths just so we don't get any values mixed up. This is how we're gonna find the perimeter right here, all right? Now this won't do for our equation because it wants us to solve this. Well, I guess I'll write an equation that will help you solve this application problem. This, I suppose you could argue that this would help, but it's not the one that they want. Okay, so we gotta fix this. So we're gonna go back to the triangle or the rectangle here. We got length and width, and the perimeter is fine that was given in the problem, but it says also that the length of the rectangle is 1 foot more than triple the width. So my length is actually, I would probably say that I would triple the width first, but it's 1 more than that. So I'd have to have 3 of my widths plus 1. That would give me 1 individual length right there. So now I can go and take my equation, and I guess I've kind of started there. And this would be one part of the problem, right? So you say your perimeter, I'm going to rewrite the original equation there. Perimeter equals length plus width plus length and plus width. You may be wondering why there's so much space for the lengths. That's because I'm going to start replacing it. Okay, because I definitely don't want 3 variables in my equation. I would like only 1. Well, with the stuff that we wrote here, length is 3 of the widths plus 1. I can replace those lengths in the equation. So that's what I will do. My length is actually 3 of the widths plus 1. 3 times the width plus 1. And I'll do that with the other part as well. So 3 times the width plus 1. Boom. This is my equation. But the problem right now, at least the way that I've started this, is that I still have one individual unknown, the perimeter, right? But they gave us the perimeter, thank goodness. Otherwise, we end up with infinite solutions. More on that later, but that's 257. 257. Now, I did say that there's different ways to write the perimeter for perimeter formula for rectangles. This is just one of the equations that will work. We've seen it before where they double the length and double the width, and that would work also, but this is the one that I really like, so I'm going to go with it. So this last part here, just got to solve the equation, right? Well, no problem. We got a lot of widths there. So we got 3 widths. Let's combine all of our widths now. 3 widths. There'd be a 4th width, and then 3 more would make 7 widths, and then another width would make that 8 widths. Okay, so I'm just combining like terms to make this smaller, and then I have constants of 1 and another 1, which would be positive 2. And this is going to equal the 257. So this is the simplified formula or equation that we had started with. I'm going to need 2 principles of equality to solve this, though. So the first one here, I'll give myself more space. But I want to isolate those 8W's, meaning I just want them all by themselves. So I don't want that plus 2 with my 8W, so I'm going to have to subtract 2. But if I do it to one side, I do need to do it to the other side. And again, the purpose of this is to force that 2 to become a 0, which allows the 8W to be written all by itself and isolates it. And 257 minus 2 would give me 255. Wait, we'll still finish. So my 8W's, that's 8 widths. If you took 8 of those widths, you'd get 255, in this case, feet. But we just want one width. So again, to make that 8 widths, just divide it by 8. But if you do, take the 255 and divide it by 8 as well. Again, a principle of equality. But again, I'm just going to use my calculator for this. So 255 divided by 8. Now it's going to give me a pretty ugly decimal. It shows 31.875. But we did talk about how to change. Maybe we didn't. If we didn't talk about how to change decimals to fractions, either way, if you go to the bottom right of the calculator we're using, you'll see the enter button. Immediately above that is a double arrow button. I don't have to push anything else right now. I just push the double arrow button and it just gives me the fraction 255/8. Now again, this is a pretty ugly fraction, which you may get from time to time. And yeah, we do need a label for that for feet. Now that's just the width. It says what are the length and width of the rectangle at the very top there. So we know we need the length as well. So we remember that the length though is 3 of the width plus 1. Well, we just found that the width is 255/8, so I'm going to replace that with 255/8. Now again, at this point, just solving for our length, which is what we're doing, some students get pretty intimidated by that fraction. It is a pretty ugly fraction. But once again, we can use the calculators to solve this. So I type in 3 times, I'm pushing my N over D button, 255/8. I get out of the fraction, plus 1, enter. And I get another ugly fraction, but it should work, 773/8, and that should be in feet. Okay, now if I've done this right, I should be able to take 773/8. So I'm just gonna check my work here. Okay, so I'm gonna take a length, and then I'm gonna take a width, 255/8. And if I add these together, in fact, if I add them together twice, I should get the actual perimeter, which was 257. So I'm going to just check. But again, I'm just using the calculator to check. I'm not actually doing that by myself. So if I add the first two, I get 257/2. Let's add another 773/8. Oh, and then another 255/8. And yeah, I got 257. So that does check off. With these two values for length and width, it actually does check off. And so I know for sure that my length and my width, with labels, that's correct.